All right, well, good morning to you. Let's dive right into 10.2. Because of me not finishing everything on time, like always, like my whole life, we're going to need to move back to exam. So, exam number 3 will be moved back to, not next week, but the week after, Monday, Tuesday. So it'll be Monday, the 27th of March, and Tuesday. It's a 2-day, same kind of thing. So Monday and Tuesday, the 27th and 28th. So week after next, Monday, Tuesday, will be exam number 3. So the plan is to finish 10.2 today. Write that down. Homework 10.2 will be due on Monday. We'll finish it today. And it'll be due on Monday, and then all we got after that is 10.3 and 10.4 to do next week and review, and then we'll take the exam the Monday, Tuesday after. Make sense? So we have 4 exams in the final. So we have 2 exams left, and we have the final exam left. So if this last exam didn't go as well as you wanted, there's chances to improve things. All right. Let's dive in. So find the vertex, focus, and directrix of the parabola. All right, so first thing is to decide, does this thing go up, down, right, left? They're not requiring a picture, but I think pictures are always helpful. So first of all, let me give you a second. See what you remember from yesterday. You haven't been able to think about anything else all day with parabolas, right? You were sitting in English class, and you were thinking parabolas, up, down, right, left. You were watching TV at night, and you were thinking parabolas, right? Maybe I'm making too much of my class in your mind. All right. So that will go up, down, right, or left. What tells us? Where do we look to see that? We're looking at the equation x squared is 25 what? Who tells us which way the thing goes? The first power letter. That's the unique mark of a parabola. He's got a first power letter. Right? The other ones we're going to do next week, 10.3, 10.4. Everything's going to be squared. There's going to be no first power letters anywhere. X will be squared and y will be squared. But the unique characteristic of parabolas is one letter is squared, the other is not. And the one that is not tells us the direction, huh? So it tells us y, and what is that 25? Is that a positive 25 or a negative 25? It's positive, huh? So it's positive y. It's going up. This is a parabola going up, isn't it? All right, positive y up. Because positive y. All right. So anyway, we know it's probably going up. So first off, what's the center? They're asking me for the vertex. Vertex means center, right? Vertex is center. What's the center of this thing? 0, 0. And I know that because there's no, like if they had x minus 3 squared is 25, y plus 2, or something like that, then I would do opposite. Right in the center would be positive 3, negative 2, or whatever. You with me? Only if there's numbers in parentheses right next to x and y has the center been moved, has the center been shifted. But in our case, we have no parentheses, nothing added or subtracted next to x or next to y. So the center, the vertex, is 0, 0. So it's centered at the origin. It goes up. That's generally how this parabola looks. We know 2 crucial things, centered at the origin, going up. Next, focus. Where's the focal point? How do we find that? I would be so impressed if anybody, if you want to impress me, I'd be impressed. If you care about impressing a teacher. I would be very impressed. I would be surprised as well, if anybody just knows the focal point. Where's it? Uh-huh. Right. That's it. I'm impressed. Good job, Kelton. The focus point is 25 fourths. Now, how does Kelton know that? Because he's probably done some homework. But let me give you the game plan. Remember the general format of how the parabola equation looks. It's x squared is 4ay, or y squared is 4ax. In our case, we have the x squared, right? So that's the general form, right, of the parabola equation, right? 4ay. And the a, remember, is how far to the focal point. So the a is, so whatever, wherever the focal point is, the distance from there to there is a. You with me? And the focal point's always inside the parabola, right? So I just got to find this a. Well, what do we really have? We have x squared is 25y. That's our actual equation, right? The form is x squared is 4ay. Remember there's an automatic 4 out there because of what happens when you derive the thing. And then there's a 25, which means 4a has to equal 25. Do you see that? In other words, what is a so that 4a is 25? Or in fact, I bet I'm confusing you. Well, not totally confusing you, but I bet I can say it even easier. A way that'd be easier. Just look at that. What does that a have to be? 4 times what times y to really be the same as 25y? I was just telling my algebra students yesterday, a lot of math is what I call plastic surgery, removing the wrinkles to give it a new look without changing anything. Isn't that a lot of math, right? So that's what we're doing here. We're saying, look. I've got this general form. I want to make it look that way. I want to give it that look, because when I give it that look, it's easy for me to graph, right? So I want to make it look like 4 times something times y. But really, it's just 25y, right? But I can change the way it looks without changing the actual value. So how can you make it look like this, but still really be 25? 4 times what is really still 25? 25. Well, let me do a different color to be more clear. What is it? 25 fourths. Because those 4s would just cancel, and that's still a 25. And now it's got the look we need to graph. So my a is 25 fourths. Did you catch that? Did you follow that? That's so much of math. Want to dial in with that plastic surgery thing. We're doing that all the time. Making things look different without being different. Right? I just gave it a look with a 4. Because why? Because they've told me, hey, if you can get a 4 out front, then that next thing will be your focal point. So I think, okay, I got to make that 25 look like it's got a 4 out front without really changing it. I can't change the problem. So 4 times what is the same as 25? Well, you just put the number over the 4 and the 4's cancel. It'll always be that way, you see. That's just a 4 times 25 fourths is just a fancy way of saying 25, isn't it? But now I know what a is. A is 25 fourths. So my A is 25 fourths. Just use your calculator. What is that, 6.25? 6.25. So there's my A. And a test, I don't care. Decimal fraction, whatever. I'm happy with all of them. As long as it's right, I'm thrilled. So the focal point then is over 0 up 6.25. Or 25 fourths. I don't know if Matthew still wants a fraction. They might want a fraction. Give them what they want on the test, I don't care. Is that good to there? So we're finding the focal point? And they also want the directrix. Remember what the directrix is? I don't know if I've been very clear on the directrix. It's the line right behind the parabola, same distance to the other side. So let me say that again real clear. The directrix is the same distance as the focus point, but it's behind the parabola, directing it from behind. So the directrix line is a dotted line, almost like an asymptote line. It's not really an asymptote line. But it's dotted because it's not part of the actual graph, right? So it's a dotted line behind the parabola, always behind. The focus is inside the parabola, always. Right? So like, for example, if you have a parabola going to the right, the focal point will be here, the directrix line will be back there. Get the idea? The directrix line is always behind the parabola, the focus point is inside, and they're both the same distance. Oh wait, they're both a. That a distance is the distance from the center, the vertex, the center, to the focus, and backwards to the directrix. A in both cases. So, therefore, that a, that 6.25, and in this case it's negative, huh? This hits the y-axis, so this is y equals negative 6.25. That's the directrix line equation. Tim?
What's the purpose of the directrix?
Yeah, that's the derivation, which I invited y'all to come to my office hours, and I'll show you about it. Remember, I just said the one line. What a parabola is the set of all points that are equidistant, same distance from the directrix line and the parabola. No, directrix line and the focus point. I spaced out for a minute. So let me finish this question and I'll answer that. So everybody so we're done with this question. This is the directrix. This just looks so messy to me. I feel like I didn't really answer it. Directrix line is right there. Y equals negative 6.25. Does everybody see that? That's the directrix. And how did I come up with that? It's the same distance as the focus. It's the A, but it's backwards. So negative 6.25. We get the focus point, and the vertex is 0, 0. We're done with this question. Robert, question?
No, I was just gonna say, because we know that, I see what you did right there.
Uh-huh.
You know, I'm trying to find, what A was. But since we know that 25 is actually 4A.
Right.
We just say 4A equals 25.
That's right. That'll work too. That's right. Yeah. Yeah. So real quick, what if I just said, hey guys, here's a dotted line, and here's a point. This is back 4, and this is over 4, or whatever. And I said, hey, tell me all the points that are exactly halfway between this line, this directrix line, and this focal point. What are you think? Well, this point, isn't that point exactly halfway between? Yeah, sure. Now you might think you'd be wrong if you thought, well, that point too. Not true. This point is only this distance away, 4, and it's further away from the focus. That point is not halfway between. So he's not on the parabola. Where do you need to? You need to go over a little bit, don't you? Whoops, come on. About like right there would probably be about right. You got to get. Now see that looks a little closer to the focus. That's probably this dot is probably also same distance from the line. Remember, when you talk about the distance from a line, you mean straight to the line, right? So this point right here is probably about halfway between the line and the point. And this point, 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 you get the parabola. That's what the parabola is all the dots that are exactly same distance from a directrix line and a focal point. They are making the parabola. That's what it is. Anyway, we don't got time for that. That's the derivation. Come off stairs. Be glad to show you. But that's behind the scenes what led to all the 4 pops out of that. That's why we have this. All right, try that one. Let's start with the vertex, which means center, right? You can do the center without doing anything, right? Just nail out that center. Let's have a race. What's the center? 2, -1. Done, right? Because the center is always opposite of the x. So positive 2, opposite of what's next to the y in the parentheses. Right? Opposite, opposite. That's for all these equations, right? All 10, 2, next week 10, 3, 10, 4, it's all the same. Whatever's next to x, next to y, parentheses, opposite, opposite, center. There's center. Okay, now, for the rest of the questions, focus point, directrix, you're going to need to draw a picture. Even though they don't say picture required, it'll really help. It's the best way to go. So draw yourself a rough, it doesn't need to be exact or anything, but just a rough little picture. It's over 2, down 1. There's the center, right? Over 2, down 1. Start with that center. From that center, the parabola is either going to go up or down or right up. Don't say it out loud. Give everybody a chance to think about it. But you got to figure out, the first thing you got to figure out is this parabola going up from that center, down, right, or left. So let me give you a second. Let everybody have a chance to figure that out. Where do you look to find the answer to that question? Up, down, right, or left? Who tells you that? Who holds that information? First power letter. First power letter. Who's the first power letter in this problem? X. And then ask yourself, so X, so right away we know it's right or left. Because it's X. It's either right, if X is positive, or if it's left, if X is negative. What's in front of that X? Positive or negative? Positive 2, right? Parabola's going to the right. Make sense? So right away we know this parabola is going to the right because positive X, first power, the first power letter, right? Positive 2, whatever, X. It's the multiplier. We're talking about the multiplier in front of X. Positive 2. You guys with me? It's the multiplier, not the subtraction 2. That just moves the center. That has nothing to do with right or left. Right? It's the multiplier in front of X. Positive 2, right. Okay, so use that to find the focus. Focal point. So what you're thinking, I hope, is you're thinking about doing a little plastic surgery, right? The general form is 4A. And we've got 2. Right? You got to do a little plastic surgery. You got to give it a new look. Right? You got to put something in here, which we call A, so that 4 times what is the same as 2. Got to make it look different without being different. So remember what you always do? You just take whatever number you got here and put it over 4. And then you can reduce that to half. Everybody see that? It's literally that simple. Whatever number you want to make it, if they had a 17 here, I'd put 17 over 4. Right? Whatever number, last one we had what, 25? I put 25 over 4. Right? You just put it over 4, because then the 4s will cancel and you're back to that number. Right? That makes sense? So it's kind of scribbly. It's real scribbly. Yeah, so the 2 becomes 2 over the 4's got to be in the bottom, huh? Because it's got to cancel. So that's the same as a half, really. So the A is 2/4, or I'm just going to go point. Let's make it a decimal. I don't care in test, decimal fraction, whatever. 0.5. Now what is A again? Does that mean that's where the focus is? It's at 0.5, like here or something? Or is it down the line, like 0.5 there? No, remember, A is a distance. It's not a location, it's a how far from here to there, right? A is a distance, not a location. So A is how far from the center out to the focal point, right? If they were building a satellite dish, how far out to the receiver. So it means from this center, go a half a unit and put your focal point. That's what it means, huh? Focal point's always inside the dish, right? So A again is how far from the center to the focal point. It's a half a unit. So what's the coordinates of that focal point then? This is over 1, over 2. This is over 2.5, down 1, right? Everybody good there? Am I losing you? Right, because the center, as we know, is over 2 down 1. And so we take that and add 0.5 to it. You get 2.5 down 1, huh? That's the focus. Good? In the hands, this takes practice. This will not come to the casual. This will come to those who practice. And then, what else? Oh, Directrix line. Can you find the Directrix line? And they want the equation. Whenever they say Directrix line, it's a line, so they want the equation of the line.
Y equals 1.5.
Y equals 1.5. Yeah, because it's also, this one's a half a unit this way. The Directrix line is a half a unit back, huh? The Directrix line is always opposite direction, right? So this one will be back this way. Half a unit, I'm kind of running out of room. It's supposed to be right here, huh? Half a unit back from 2. So it's at 1.5. It hits the x-axis at 1.5. That's the Directrix line. It's always behind the parabola. And we're done. Is that good? We good there? Are we happy about that? Questions? No questions? Good? All right. We'll do this one. There we go. So x minus 1 squared is minus y plus 4. All right, try that one. So start with the center, the vertex. What's the center?
1, -4.
1, -4. Opposite, right? 1, -4. Good. All right, take it from there. So I would put it on a graph at this point and decide if it goes up, down, right, or left. So which way does this one go? Up, down, right, or left? It's got negative y to the first power. Negative y, down. It's going down, right? Remember, first power letter, the multiplier in the front. Negative y. So where's the center? Over 1, down 4. There's the center going down. Good so far? Now, where's the focal point? Well, somewhere here, and the directrix line is going to be behind it. I just got to find the particulars. That's generally the look, right? Focal point down here, directrix line back here, right? Directrix line is always behind the thing, and focal point inside the thing. All right? I just got to find that A, and I'll know how far from this center, from this 1, -4, up to the directrix and down to the focal point, right? From this 1, -4 dot. What's the A? Well, you got to give it the look. You got to give it the A thing. So 4A y plus 4. Does that make sense? So we really have minus, which means -1. So what does A have to be?
Negative 1, 4.
Yeah, remember you just take whatever number you got here and put it over 4. That'll always work because the 4's will cancel. You'll be back to that number, right? So A is negative 1/4. So that means this A is down a fourth. Whoops, I just wrote that backwards, huh? So basically it's down a fourth here and it's up a fourth there, isn't it? So this is, and is that changing, it's up down, so it's changing the Y. So it's down 0.25 or up 0.25 on the Y coordinate. Right? Going from the point over 1 down 4, from that dot, go up and down 0.25. So then this focal point must be over 1 down 4.25, and this directrix line must be at minus 3.75. Everybody see how I found that? And that's hitting, that directrix line hits the y-axis, so y equals negative 3.75. See what I did? I just took the y coordinate. Why the y? Why not the x? Because it's up, down. We're going up, down. The A is up and down. So it's affecting the y coordinate. It's not affecting the x. It's not affecting the over 1. That's done. Right? It's affecting the y. So you add 0.25 and you subtract 0.25 from the negative 4. Huh? You get negative 3.75 and negative 4.25. So the focal point is a point. It's got an x and a y coordinate. There's the focus. Over 1 down 4.25, and the directrix line is a line equation hitting the y-axis at negative 3.75. Good? Are we happy? Questions I can answer? Are you sure? I'm glad to answer. All right. Okay, so now we get y squared minus 4y plus 4x plus 4 equals 0. All right, so this one does not at all, we got to do a lot of plastic surgery. This one doesn't have the format we want at all. It's not even close. What's the format we want? If you look back to those basic equations I gave you, since we have y squared and x is to the first power, we can tell, y is going to be our second power letter, x is going to be first. We know it's a parabola right away because one letter is squared, the other is not, huh? So we know it's a parabola right off the bat. What format do we have to get it? If you look back to the formats I gave you, they all had y squared is 4ax and things like that. In other words, they had the squared letter alone and the first power letter on the other side of the equal sign with a 4 at the end. Right? That's the look. That's the format that's easiest for us to graph. Math is always doing this. Are you getting the hang of that? That's what math is all about. They give you something in a certain look that's easy to do stuff with. Graph it or do other stuff in calculus, derivative and stuff like that. So they give you a look. So you got to take whatever you've got and make it look like that, and that requires algebra, right? So I've got to take this thing. First off, I want all the y's on one side and the x's on the other. I want to separate them. Why? Because that's the look. That's the look of those basic equations I gave you. Make sense? That's the look that's easiest for us to graph, in other words. Right? So I go, oh, okay, there's my goal. My goal is to make it, y is on one side, x is on the other. So let's just jump these guys to the other side. Y squared minus 4y is negative 4x minus 4. So far, so good? I'm moving towards the look I want. I got the y's on one side, x is on the other. Now, what's this y squared minus 4y stuff? I don't remember that. I don't remember anything looking that way. What am I going to do about that? Yeah, no. But it's not a bad thought, but let's talk about why that's not right. If I factored out the y, that's not the look. The look is y squared, or for the harder ones, it's like y minus a number, like y minus 2 squared or something. So I can make it look like that. Or just y, it can either be just y squared, which we're not just y squared. So I've got to make it look like that. Right, you with me? We've seen ones that look like that, haven't we? We haven't seen anything that looks like this, have we? That's not the look we've ever had in the 10 problems we've done. It's this, isn't it? So we got to make it look like that, don't we? Everybody see how I'm reasoning? See how I know the general look I've got to give it, right? Because we have not just y squared, but also regular y. We don't want to do this. They never look like that. They're just y squared alone or y parentheses something squared. That's the look. Okay, so what? Great, that's the look. How do we do that? How do we make y squared minus 4y look like this? That's called, you've done it before, but you don't know it out of context. You don't know it deeply enough yet to recognize it unless you're right in the homework section doing 10 of them in a row. Right? That's how your math ability needs to rise. It needs to rise to the level, that's how you're going to do the final exam. That final's coming. Right? Where you need to know it so well that you can do it outside of context. You know what I mean? There's a difference between doing homework and doing 10 of the same thing in a row and saying I can do it versus a month later, out of the blue, in the middle of some other problem, it shows up and you can still do it then too. That's when you really own that baby. This is called completing the square. Remember completing the square? This is completing the square. You did it in algebra. We did it in here, didn't we? Maybe I'm dreaming. Maybe we don't do it in here earlier. I don't remember exactly. We got to make it look like that. That's called completing the square. So to do that, what's happened? I have got to take, what you do is you take this number here, go over the side of your paper, put it over 2 and square it. Seen that before? So that's minus 2 squared, that's plus 4. You got to add 4 to both sides. This will become y squared minus 4y plus 4. The other side, these will cancel. What did I just do? I gave it just what it needs so that it'll factor now. How does that left side factor now? How do you factor that left side now? Y minus 2, y minus 2. In other words, y minus 2 squared. We gave it the look. Do you see that? Do you see what happened? So let me back up. I wanted to let you see the whole flow real quick and then talk back through it. That 4 is what I call the magic number. That's not its official name. But I think that helps people think rightly about what we're doing. It's magic. It gives it just what it needs so that it'll factor as the same thing twice. In other words, a square. It's called completing the square, making it into a square. You give it just what it needs. How do you know what it needs? You take the middle number and put it over 2 and square it. Every time, that will tell you what is needed to make it factor as the same thing twice, as a square. That make sense on that? So every time you grab the middle number, it's always the middle number, the B, we call it B, you know, the ABC, right? This is like A is 1, B is here, right? So it's the B over 2 squared. That's how you find the magic number. Turned out to be 4. Then you add it to both sides because you can't change anything. If you mess with one side, you got to mess with the other in the same way or you've wrecked the equation, right? So we got to add 4 to both sides. And when I do, these cancel. It's just a nice coincidence. I wasn't really paying attention to what was happening on the right side. Who cares? My focus was the left side because now it factors the same thing twice and thus as a square. So everybody got that? Now we can graph it. Now we can do all the regular stuff we've always done. Everybody good with that? You got those? I'm going to go to a fresh screen. But see how we completed the square there? So it's B over 2 quantity squared. That'll give you the magic number. Then you add that magic to both sides and the left side will factor as the same thing twice, as a square. That's called completing the square. Giving it what it needs to become a square. Right? Completing the square. All right, so then, after completing the square, now we just do the rest of the problem, right? You with me? Or are you getting tired of this problem? These get long. So now what do we have? We had y minus 2 squared is negative 4x. Is that what we had? Oops, let me move it up. It's kind of in the way there. So y minus 2 squared is negative 4. So once we completed the square, this becomes this. Now we can graph it, huh? I'm just going to graph it real quick because we don't have time. So what would be the center now? 0, 2, yeah, because it's opposite, which is just 0, and opposite, which is positive 2. So you go over 0, up 2, 1, 2, right there. There's the center. So this one going up, down, right or left? First power letter, negative x, left. It's going left, okay? How far? Where's the focal point? Focal point somewhere here. Directrix line back here. All right, where exactly is the focal point? Focal point's always inside. It's whatever A is. So I got to do a little bit more work on the look. Y minus 2 squared is minus 4ax. So what's A? It's just 1. A is 1. So this is a distance of 1. This is a distance of 1. So this is over 0, up 2. And I'm going back 1 and right 1 to the what? To the x coordinate or the y coordinate? It's right, left, x. So you're adding 1 and subtracting 1 to that x coordinate, huh? So this focal point will be back 1, up 2. And this directrix line is hitting the x-axis. X equals positive 1. Done. So once you give it the look, the completed square look, then you can do everything we're used to doing. Does that make sense? Shall we try another one of those? All right, so x squared plus 4x, 2y minus 6. All right, give it a go, guys. Got left. How do you know? Yeah, let me give a note. When you have x squared and x to the first power, or y squared and y to the first power, it doesn't matter. You must complete the square. Meaning what? Meaning add b over 2 squared to both sides. Does that make sense? I want to give you the identification system. Right? When you have x squared and x to the first, that's the key. We have x squared and x to the first, or y squared and y. So we see x squared and x to the first, and we go, oh, it's one of these complete the square ones. You know what I mean? If that was just x squared plus 4, for example, without an x, I wouldn't complete the square. I would just, hey, subtract that 4. X squared is 2y minus 10. And so here we go. You know, I wouldn't complete the square. Because there is x squared. He's done, right? But if you have x squared and regular x, everybody seeing that? X squared and regular x, that's when you go, oh yeah, I got to get those together in one parenthesis. I've got to complete the square. All right, here we go. Complete the square. Add b over 2 to both sides. B over 2 squared to both sides. B over 2 squared. 4 over 2 squared. 2 squared. 4. You should be adding 4 to both sides, right? All right, so you grab the b. B over 2 squared. That's 4 over 2 squared. That's 2 squared 4. So add 4 to both sides. We good so far? So then that'll be x squared plus 4x plus 4 is 2y minus 2. Like that. Good? So now, that magic number is magic. It completes it. It gives the left side just what it needs. Just what it needs to factor. Guaranteed that left side will factor as the same thing twice now. That's what it guarantees. That's the magic that it does. So what does it need? Well, I mean, how does it factor? Plus 2, huh? Well, what happens on the right side? Take out a 2. Good. So there we go. Except for the 4. We don't quite have the look yet. Yeah, let's get all the way to the final look, huh? Remember, the final look has got a 4 in it, doesn't it? So we want a 4a y minus 1, don't we? So, right? So what is that a have to be? Well, it always, this number over 4. In other words, a half. There's the look. There's the exact look that we can graph with, right? Is that good? Everybody got that copy down? Can I go to a fresh screen and graph that? Everybody got that there? So if I've got it, x plus 2 squared, 4, half y minus 1, x plus 2, y minus 1, x plus 2, y minus 1. So we've got x plus 2, y minus 1. And that's really just 0.5, huh? Just making it decimal. All right, so there it is. So what's the center of this thing? Opposite, opposite. Negative 2 plus 1. Opposite of what's next to x. Opposite of what's added or subtracted next to y. Center is back 2, up 1. Where's this parabola going? Up or down or right or left? Yeah, look at right here. We have positive y. Positive y up. Good. Positive y. The first power letter tells you the story. Okay. And so basically we're going to have a some kind of focal point up here and some kind of directrix line back here. I don't know how far back. I got to find a. What's a? Oh, a is 0.5, huh? A is 0.5. So this just goes adds 0.5, and this is going to subtract 0.5 from the what? From the y coordinate. So I'm going to take the, let me move it down here, the minus 2 plus 1 center. And I'm going to add 0.5 and subtract 0.5 from the y coordinate, huh? So the focal point will be back 2 up 1.5. Good. And the directrix line is down, is 1, take away 0.5, so it's at 0.5. So really it's like about here, isn't it? It's, and it hits the y-axis, so y is, what was it, 0.5? Y is 0.5. Because it was 1, take away 0.5. Sorry, I made kind of a sloppy mess. We good with all that? Questions? Oh, and then we got one of them word problems. Yeah, I got to get to that too. It's a long section. All right. So, all right, this is a parabola going to the left. So right off the bat, you've got to be able to say negative 4ax because it's going left. Negative x to the first power, right? So that's the general form. You just got to be able to bang right out that general form. These take practice. This is one of the harder sections, probably one of the hardest. You got to practice, 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 practice. So okay, now the center is 4, 1. So y minus 1, x minus 4, right? Opposite, opposite. I'm getting that center 4, 1 there, right? You with me? Okay, so now that's almost the whole story. Last thing, they're asking me to write the equation. Remember what I said yesterday? What does it mean when somebody says, find an equation in math? In the math world, when they say, blah, 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 find this equation, they mean only x and y only, no other letters. So what other letter do I got to find? A. They're basically saying, get your hands on A. Right? So how do I get A? They're giving me, I don't have time to let you think about it. They're giving me 3, 0 on the graph. Remember, if a point is on, I already used the center 4, 1. They're also giving me 3, 0. When somebody gives you a point that's on any kind of picture, that's the parabola. That means it makes the thing true. That's the membership requirement for getting to be on the graph. Plugged in, you make the thing true, right? So 3, 0 is on the graph. So that means if you plug in x3, y0, plug in y0, x3, it's got to make this thing true, doesn't it? And what was x3? That's got to be true, huh? So I can solve for A. This is negative 1 squared. This is 1. This is -1. That's 4a is 1. Right? Divide by 4. A is a fourth. So what's my equation? Well, on the screen there. Equals minus 4a x minus 4. But now I know what a is. Come on, baby. There we go. A is 1/4. And what do these do? They cancel. Minus 1, x minus 4. That tells you. And I don't care on a test. You can leave it this way. You don't have to cancel those. On a test, I don't care. Leave it this way, leave it that way. They're both good to me. They're both right. I'm just doing that to help us know which option, A, B, C, or D. Is that good? Seth?
You can't plug 4, 1 in because it's a distance. So
You could. Everything would cancel out. If you plug in 4 for x, what do you got there? 0, 1. 0 equals 0. Get you nowhere. Because we've already used it. When you try to reuse it, it goes, I've been used. 0, 0. No help. Yeah. The other one's the only help. So it's not illegal. It's just not helpful.
you're not going the distance.
Won't go anywhere. Yeah. All right. 4. All right. Searchlight. Shaped like a paraboloid of revolution. We talked about that, right? Searchlights, headlights, flashlights, they have a problem. If the light is 2 feet, if the light source, the lamp, is 2 feet from the base along the axis of symmetry, and the opening is 12 feet across, how deep should the searchlight be? In other words, where should they put the focus point? That's what they're basically saying. You're engineering this thing. You want to know where the focus point is. I love to put these on the exam. They're usually on the exam because I think they're valuable. I mean, this is math applied to the real world here. So now, how are we going to do that? This is where I wish I had a half an hour to talk about this because there's so many great things in this problem. Here we see the beauty of analytic geometry, which is what we're doing. What is analytic geometry? You remember geometry, right? You took geometry, right? Circles and lines and all that. Well, if you just tried to do this problem by geometry alone, it'd be hard. I couldn't do it. It'd be super hard. But we're going to use analytic geometry, which means algebraic geometry. Which means what? Parabola equations. You see, that's what a parabola equation is. It's taking pictures and putting equations to them, right? When you put equations to pictures, that's called analytic or algebraic, same thing, geometry. That's what all these sections are. So what I'm saying is, I'm just going to say, well, I don't know if that searchlight is pointing up or pointing right or what. I'm just going to say, let's just say it's going up. You could do it to the right. It doesn't matter. You're making it up. Remember, math is made up to help you describe things that are real. And here we see that perfectly. So in other words, when you have a searchlight out there, when the engineers designed the searchlight, there's no axis system sitting there at the bottom of the searchlight. We're making that up, right? We're making that up because it makes it so much easier to solve things. That's called algebraic geometry. We're putting algebraic equations to pictures. So we make up an axis system, and we set the thing in a nice place. Notice I don't just set it like way up here or something weird like that. I set it right at the origin because that's easy for me. And then I say, okay, let's just put that little parabola there. What are they saying? The light source is 2 feet from the base along the axis of symmetry. So the light source is 2 feet up here. And the opening is 12 feet across. Wait. The light source is 2 feet from the base along the axis of symmetry, and the opening is 12 feet across. Right. So they mean this is 6 feet in each direction. So it just stops right here. Like that, right? Does that make sense what they're saying? So the light source is 2 feet from the base, and the opening, my picture's not so good, but it's 12 feet across altogether. And they're saying, how deep should the searchlight be? All right, so they want me to find the focal point. This one is worded funny, isn't it? I don't like how it's worded. A searchlight is shaped like a parabola. If the light source is located 2 feet from the base along the axis of symmetry, and the opening is 12 feet across, How deep should the... Oh, no. A good thing I read more carefully. Wrong-o, Mr. Brett Herron. Let's try again. They're saying, when they say the light source is 2 feet, that is the focus. The light source is the focus. They put it at the focus point, right? So that light, when it shines back here, it bounces everything straight back. So that is the focus. They're giving me the focus, and they're telling me the total width here is 12, which does mean 6 each side. And they're saying, how deep is the light? They want the total height, right? They're telling me, here's the focus. How deep's the whole light? How deep should we make the whole light if we want to make it 12 wide? That's what they're saying. They're doing it backwards. Okay, so how do we do that? Well, what's the general equation? Hold on with me just 1 minute here. We'll get this. What's the general equation? Up, down, right, or left? Up. So it's x squared is plus 4ay. You could have made this whole thing go right, and we're just as fine. The a, what's the a? 2. That is the focal point. They're giving it to me. So I got x squared is 8y. Okay, so what? Now I want to find, what's the coordinate? This is a dot. What's that dot? It's over how far? 6. Up, I don't know. Y, and that y is my depth and my answer. Am I losing you? Do you see that? Right, because it's 12 all the way across, right? This 12 is all the way. So it's 6 each way. This is back 6. This is over 6, right? And this is up y, and that y, that up, is my depth. Is what they're asking for, the depth of the light. So plug in 6y to x squared is 8y. Plug in 6 for x, and y is y. So 6 squared is 8y, meaning 36 is 8y. Am I on the screen? No. Just, so that's 36 eighths and we're done, right? Is everybody okay with that? I just don't have room. 36 over 8y divided by the 8. 36 eighths. And then reduce that. What is that? By 4, 9 halves. So the 4.5. 4.5. That's how deep. The light should be 4.5 feet high. All right, I wish I had time to do a lot more of those with you. Come see me. I'd be glad to help you.